Imagine a world not of arid desolation, but of blue skies and sprawling oceans. A world where rain fell on unfamiliar continents and volcanoes pierced an atmosphere thick with possibility. Billions of years ago, this was Mars. The red planet we see today, a frozen desert with a whisper of an atmosphere, is merely a ghost haunting the solar system. Its surface is a crime scene, etched with the fingerprints of a violent and mysterious past, waiting for us to piece together how this vibrant world died, while its sister, Earth, thrived. This is the story of a planetary catastrophe, written in the scars of a world that was once startlingly similar to our own. Mars is a small world, just over half the size of Earth, yet it shares a remarkably familiar rhythm. A day on Mars lasts almost exactly the same as a day on our planet, a comfortable span that would feel instantly recognizable to any human settler. This similarity, however, is an illusion. A single year on Mars stretches to nearly twice an Earth year, a testament to its longer, slower journey around the sunday. Its gravity is weak, less than half of what we experience on our planet, meaning a person who weighs 100 units on Earth would feel as light as a child on Mars. Yet, despite its diminutive size, its landmass is roughly equivalent to the entire surface area of all of Earth's continents combined. This is the stage for a tragedy of cosmic proportions. The story begins in the hazy dawn of the solar system, nearly 5 billion years ago, with the formation of Mars from the swirling gas and dust that surrounded our young Sunday. Its core, rich in iron, nickel, and sulfur, likely generated a protective magnetic field, shielding the young planet from the sun's harsh solar wind. For hundreds of millions of years, Mars was a water world. Rains fell, rivers carved deep channels, and a vast sea, known to scientists as Oceanus Borealis, may have covered a significant portion of the planet's northern hemisphere. The evidence is carved into its very rocks, from the rounded pebbles polished by ancient streams discovered by rovers traversing the dusty plains, to fossilized deltas that resemble river mouths found on Earth. Temperatures were moderate, perhaps averaging a comfortable range similar to a mild spring day on our planet, making it a world where, had we been there, we could have stood and looked out over a landscape not unlike our own. This Martian paradise was also home to the solar system's most colossal features. Rising from the Tharsis region is Olympus Mons, the largest known volcano in the entire solar system. It is a shield volcano so massive that its base is as wide as an entire American state, and its peak is 3 times the height of the tallest mountain on Earth. Adjacent to this volcanic bulge is Valles Marineris, a canyon system that dwarfs the Grand Canyon. It is a scar on the planet's face, stretching longer than the entire continental United States and plunging deep enough in places to swallow the deepest chasms of our world. These features were forged during a period of intense geological activity, fueled by the internal heat of a still-living world. But the forces that built Mars also sealed its fate. Its smaller mass allowed its interior to cool much faster than Earth's. This geological death had catastrophic consequences. As the planet's liquid iron core solidified, it stopped generating the protective magnetic field that had shielded it for eons. Without this invisible shield, Mars was left vulnerable to the sun's unrelenting assault, the solar wind. The solar wind, a relentless stream of charged particles from the sun, began to strip away the Martian atmosphere. Data from orbiting spacecraft has directly measured this process, observing how the sun's particles interact with the thin air and literally blow it away into space. A catastrophic double blow then sealed its fate. Around the time when life was first emerging on Earth, a period known as the Late Heavy Bombardment saw a surge in asteroid impacts across the entire inner solar system. Mars was pummeled mercilessly. It is estimated that an enormous mass of rock fell on every square meter of the planet. This violent pounding, combined with the relentless solar wind, spelled the end for the Martian atmosphere. With the atmosphere gone, the planet's surface pressure plummeted and temperatures dropped dramatically. The vast oceans either froze, sublimated into gas and escaped, or were trapped as ice beneath the surface. The rivers dried up, the volcanoes went quiet, and the planet's surface was left as the arid, rusted desert we see today. The iron-rich minerals in the Martian soil reacted with the trace amounts of oxygen and water left in the atmosphere, turning the planet a deep, rusty red. This dramatic climatic shift is the central mystery of Mars. While Earth was recovering from the same bombardment and, remarkably, giving rise to life, its neighbor was slowly suffocating. The difference, according to scientific consensus, was fate and size. Earth's larger size allowed it to retain its internal heat, keeping its magnetic field active and protecting its atmosphere, which in turn sustained its liquid oceans and allowed life to flourish. Mars, the smaller twin, cooled, lost its shield, and succumbed to the sun's assault. For centuries, the idea of life on Mars has captured the human imagination. Early astronomers, peering through telescopes, saw dark lines on the surface they believed to be canals built by a dying civilization. We now know these were optical illusions, but the dream of Martian life persists, grounded in new scientific logic. If Mars was once so similar to Earth, could it have also given rise to life? We have found the building blocks of life, including water, organic carbon, and energy sources, on Mars. The question is, did these ingredients ever combine into a living organism? Rovers are actively exploring ancient lakebeds, searching for chemical clues that could reveal if microbial life once thrived there. If life ever existed on Mars, the evidence is likely still there, perfectly preserved in the dry, cold tomb of the planet. The exploration of this tomb has been one of humanity's greatest triumphs and frustrations. Since the first spacecraft captured the first grainy close-up images more than half a century ago, we have relentlessly probed the planet with a fleet of orbiters and rovers. Early landers conducted the first biological experiments on the surface, yielding results that remain controversial to this day. Rovers have traversed the alien terrain, revealing a planet with a history written in stone. Today, an armada of spacecraft from nations across the globe operate in orbit and on the surface, acting as our eyes and ears in a world we cannot yet visit. Each mission brings us closer to answering the fundamental question: did Mars ever host life? And what does its story tell us about our own planet's fragile existence and our potential future among the stars? Mars is a cautionary tale, a stark reminder of a world that died, and a beacon calling us to explore the mysteries of our own past and the possibility of a new home in the vast, unforgiving cosmos. The future of Mars is no longer just a matter of scientific inquiry. It is a goal for human ambition. Plans are being developed to send the first humans to the Red Planet within the coming decades. The challenges are immense. The journey takes months, the radiation exposure is severe, the dust is corrosive, and the landing is treacherous. Yet, the allure is undeniable. Mars offers resources, including water, ice, carbon dioxide, and minerals, which could be used to produce fuel, breathable air, and building materials. This concept, known as in situ resource utilization, is the key to sustainable human presence. The first footprints on Mars will not just be a symbolic achievement. They will mark the beginning of a multi-planetary species. We will build habitats, grow food in controlled environments, and, perhaps, over centuries, begin the process of terraforming, slowly warming the planet and thickening its atmosphere to make it more Earth-like. But with this ambition comes profound ethical questions. Do we have the right to alter an entire world, especially one that might harbor its own native life, however microscopic? Should we protect pristine Martian environments as we do wilderness areas on Earth? These are not just scientific or engineering problems, they are moral dilemmas that will define our generation. The exploration of Mars forces us to confront our responsibilities not just to our own planet, but to the cosmos itself. In the end, Mars is more than a planet. It is a mirror, reflecting our own past, our present ambitions, and our deepest existential questions. It is a world that died, a world that awaits our arrival, and a world that will forever change how we understand our place in the universe.